Hello, my dear students of third prep. I'm happy to be with you this year, and I wish I could benefit you, inshallah. This year is somewhat specialized because of what happened last year and the presence of coronavirus, of course, in which we left some lessons, we didn't study it. So we are going to study them this year at the very beginning. Then we are going to continue our third prep syllabus. Today we are going to start our last year syllabus, which is the similarity, the lesson of similarity, and the lesson of Pythagoras theorem, converse of Pythagoras theorem. We are going first to start by these two lessons. Then we are going to continue our geometry syllabus of third prep. Now let us start our syllabus this year. Our lesson today is similarity and converse of Pythagoras theorem. At the very beginning, we are going to start by the similarity, the meaning of similarity, and how can we use it to solve some problems. Let us see. If you have some geometric figures as those in front of you, some geometric figures, squares, circles, triangles, rhombus, whatever, parallelogram, and so on. You have some geometric figures, and I want you to look at them carefully. What are you going to notice? Yes, there are some congruent figures. So I'm going to ask you, which figures are congruent? Yes, of course, yes. A and I are congruent, which look like that. Why are they congruent? What's the meaning of the word congruent? Do you remember? Congruent means that they are exactly the same in the shape and in the size. Are these two figures the only two congruent figures? No, of course not. There are two other congruent figures. What are they? Yes, they are C and E, which look like two triangles. One is upside down and the other is right. Then you are going to check carefully that you have other figures which look like each other but not in the same size. So what about the figures A and J or I and J? Yes, of course, they look like each other but different in size. So here in this case, we can say that the figures J and A, yes, are said to be similar. And what also? I and J. So figure I, and figure J are said to be similar. What's the meaning of similar? It means that you have two figures looking like each other, but one is small and the other is big. Like what? Give me an example. Yes, of course, like you and your picture. The two shapes are the same. Your picture is like your own shape, but in different size. The picture is small and you are the big one. So in this case, we can say that you and your picture are similar to each other, look like each other, but in different sizes. So we can say that if you have two polygons, polygon A, B, C, D, E, another polygon X, Y, Z, L, M. Do you notice? Measure angle A equals measure angle X. measure angle B equals measure angle Y, and so on. In this case, we can say that the two polygons are similar. The two polygons A, B, C, D, E and X, Y, Z, L, M are said to be called similar polygons. When can we say this? We can say this if the corresponding angles are equal in measure. This means that measure angle A equals measure angle X, and so on. And also corresponding sides are proportional. What's meant by corresponding sides are proportional? Let us see. Measure angle A equals measure angle X, so two corresponding angles are equal in measure. What else? Yes, measure angle B, the second letter, equals measure angle Y, the second letter in the other polygon. What about measure angle C? Yes, it is equal to measure angle Z, so it is the third letter in the first polygon equals the measure of the third letter in the other polygon. What else? Do you know? Yes, that's correct. It's measure angle D equals measure angle L, as they are the fourth letters in the two polygons. And finally, we can say that measure angle E equals measure angle M. The last two letters are having the same measure. These are what's the meaning of corresponding angles are equal in measure. What about corresponding sides are proportional? Yes, the first side is AB in the first polygon. What about the first side in the second polygon? XY. So we can say that AB over XY equals BC over YZ, the second side with the second side. Third side CD, third side in the other polygon is ZL, so CD over ZL equals DE over LM equals AE over XM. And this is what called corresponding sides are proportional and not equal. Why? Why not equal? Because if the corresponding sides are equal, then the two polygons are congruent and not similar. To be similar, the corresponding sides must be proportional. Take good care. Two polygons, A, B, C, G, and another polygon, D, E, F, G. And these two polygons are similar, like that in front of you in the figure. Then I want you to complete. First of all, what about measure angle A? It is equal to what? Yes, measure angle A, it is the first letter in the first polygon. It is equal to measure angle D, which is the first letter in the other polygon. So measure angle A equals measure angle D. Then measure angle C equals what? Can you answer? Yes, that's correct. It is equal to measure angle F, as it is the third letter with the third letter. They are equal, and if you look carefully to the opposite figure, you are going to notice that they are equal in measure. To find their measure, of course, yes, the measure of the angle is 180 degrees, so measure angle A equals what? Equals measure angle DGF, so it is equal to 180 degrees divided by 2 to give an answer as 90 degrees. Then, in the same figure, if the length of AB equals 5 centimeters, BC equals 4 centimeters, AG equals 8 centimeters, and DG equals 10 centimeters. I want you also to complete. Then, DE equals how many centimeters, and EF equals how many centimeters. Then, look carefully. We have said before that the sides must be proportional. So in this case, we can say that AB over DE equals BC over EF equals AC over DC. By substituting by the length of the opposite sides in front of you, we are going to notice that AB equals 5. So instead of AB, we'll put 5 over DE equals, instead of BC, we put 4 over EF equals, instead of AC, we are going to put 8 and DC equals 10. Then, by making cross multiplication, do you remember cross multiplication? You are going to find that DE equals 5 multiplied by 10 over 8 to give a length as 6.25 centimeters. Then, to find the length of EF, also by using cross multiplication, you are going to find that EF equals 4 times 10 over 8 to give a result as 5 centimeters. Now, let us have another example. Two triangles are similar. We have taken that the two polygons are similar and we have taken an example. What about the two triangles are similar? When? When are the two triangles are said to be similar triangles? If one of the following two cases is permitted. So, if corresponding angles are equal in measure or corresponding sides are proportional. Take care. If one of them is succeeded, so the other is okay and the two triangles will be similar. Then you are going to notice that triangle ABC is similar to triangle DEF as the figure opposite to you. All of you know that the first letter equals the first letter. So here we can say that measure angle A equals measure angle D. The corresponding angles are equal in measure. So we can say that measure angle B equals measure angle E. And finally, measure angle C equals measure angle F. Then, what about corresponding sides are proportional? Can you tell me? Yes, what about the corresponding sides? AB, its corresponding side is DE. So we can say that AB over DE equals BC over EF equals AC over DF. And here we can say that proportional sides. These are called proportional sides. In the figure opposite, you have measure angle A equals measure angle E, and BD bisects measure angle B. Then I want you to prove that triangle ABC is similar to triangle EBD. And then to find the length of DC. First of all, we have to prove that two triangles are similar. Now, do you remember how can you prove that two triangles are similar if the corresponding angles are equal in measure? In this case, you are going to look carefully at the given. Measure angle A in the triangle ABC is equal to measure angle E in the triangle BED. So you have an angle equal to another angle in the second triangle. And BD bisects measure angle B. It means that measure angle ABC equals measure angle DBE. So another two angles are equal in measure in the two triangles. Then, can you now prove that the two triangles are similar? Let us see. And if the length of AB is 5 centimeters, EB equals 8 centimeters, and BC equals 6 centimeters. So we want to find the length of DC. Then, first of all, you have measure angle A equals measure angle E, given. And then measure angle ABC equals measure angle EBD. Two angles in one triangle are equal to another two angles in another triangle. So you are going to deduce that the measure of the third angle equals the measure of the corresponding three angles of the other triangle. So in this case, we can say that triangle ABC is similar to triangle EBD. Then you have two similar triangles, so corresponding sides are proportional. So we can say that that's correct. We can say that AB over EB equals BC over BD equals 5 over 8, which is equal to 6 over BD. By making cross multiplication, you now can find the length of BD. It is 6 times 8 over 5 to give a length as 9.6. Then you want to find the length of DC. How can you? Let us see. First of all, you are going to notice that BD equals 9.6. So BD equals 9.6. So DC equals 9.6 minus 6 equals 3.6 centimeters. Another example. In the figure opposite, the length of AD equals 7 centimeters, AE equals 6 centimeters, and triangle AED is similar to triangle ABC. And finally, the length of AC equals 14 centimeters. And I want you to find the length of BD. You have two similar triangles, of course, which are, yes, triangle AED is similar to triangle ABC. Here we can find corresponding sides which are proportional. So we can say that AE over AB equals ED over BC equals AD over AC, proportional sides. Then by substituting, you are going to find that 6, which is AE over AB, equals 7 over 14. By making cross multiplication, you are going to find that AB equals 6 times 14 over 7 to give a length as 12 centimeters. Now the length of AB equals 12 centimeters. Then, what about BD? You have the length of AB 12 and the length of AD is 7. So we can find the length of BD as 12 minus 7 equals 5 centimeters. Then, what about the converse of Pythagoras' theorem? You have studied in the previous years Pythagoras' theorem itself, which denotes that there must be an angle of measure 90 degrees in a right angle triangle, in a triangle. So here we are going to prove that this angle will be of measure 90 degrees. So converse of Pythagoras' theorem says that in a triangle, if the sum of areas of two squares drawn on two sides of it equals the area of the square on the longest side, then the triangle is right-angled triangle. So the given will not be right-angled triangle. You are going to prove that it is a right-angled triangle. How? First of all, look carefully. If you have triangle ABC, and if the length of BC squared equals AB squared plus AC squared, which is the rule of Pythagoras theorem, then you are going to notice that measure angle A equals 90 degrees. It means that the triangle is right angle triangle at A. Then we are going to take or have some examples to obtain this result. In the opposite figure, measure angle C equals 90 degrees, AC equals 9 centimeters, BC equals 12 centimeters, BD equals 20 centimeters, and AD equals 25 centimeters. Then I want you to prove that measure angle ABD equals 90 degrees. First of all, you are going to check triangle ABC. Why? As triangle ABC is right angle triangle as measure angle C equals 90 degrees. Then you are going to use Pythagoras theorem, which you have studied before, which says that the length of the hypotenuse AB power 2 equals the sum of the squares of the length of the other two sides, which is equal to AC to the power of 2 plus BC to the power of 2, which gives a result as 9 to the power of 2 plus 12 to the power of 2, and gives an answer as 225. Then the AB power 2 equals 225. Now, then the length of AB by taking square root for both sides is equal to root 225 to obtain a result as 15 centimeters. Then you are going to notice that AB equals 15 centimeters. You are going to take the other triangle, which is triangle, that's correct, it is triangle ABD. What is the longest side? Yes, of course, AD is the longest. So AD to the power of 2 equals 25 to the power of 2 equals 625. Find the sum of the squares of the other two sides. So AB to the power of 2 plus BD to the power of 2 equals 15 to the power of 2 plus 20 to the power of 2 to obtain a result as 225 plus 400 equals 625. And what do you notice now? Yes, that's correct. You are going to notice that they are both the same, having the same result, which is 625. So in this case, we can say that AB to the power of 2 plus BD to the power of 2 equals AD to the power of 2. And in this case, we can say that this triangle is right angle triangle at angle ABD. So measure angle ABD will be equal to 90 degrees. Let us have another example. You have triangle ABC. The length of AB equals 12 centimeters. BC equals 13 centimeters. And AC equals 5 centimeters. Prove that triangle ABC is right angle triangle at A. First of all, look carefully. What is the longest side here? It is BC, which is of length 13 centimeters. So we are going to start by the length of the longest side. So we are going to take BC, which is 13 centimeters, and find its square. Then BC to the power of 2 equals 13 to the power of 2, which gives a result as 169. What about the length of the other two sides? Yes, AC and AB, you are going to square them. So AB power 2 plus AC to the power of 2 equals 12 to the power of 2 plus 5 to the power of 2. By using your calculators, you are going to find the result as 169 also. What do you notice? Yes, you must notice that BC to the power of 2 equals AB to the power of 2 plus AC to the power of 2, which is the rule of Pythagoras theorem. So in this case, we can say that measure angle A equals 90, and we have deduced that triangle ABC is the right-angled triangle. Now, by the end of this example, we reached the end of our lesson today. I wish that all of you understood it, and we'll meet على خير إن شاء الله. Bye bye.